Hello, Shana.
Hey, Darko, how are you?
I'm very good and good evening to you.
Yeah, good night,
I hope
actually.
that it's good night. Well, that's fair. It's past midnight. So, Shana, tell us who you are, where do you join us from, and what do you do?
Absolutely. So I'm Shana Schipers. I'm a specialist solutions architect in analytics, focusing mainly on anything big data really. So EMR, Glue, Apache Spark, which I love, things like Hudi and other frameworks similar to that, data lakes, you name it, anything big data really excites me. And yeah, I'm joining you guys out of Belgium today. So it's like
Belgium.
12:30, July 8th for me now.
Okay, you coming to us from the future. It's Friday for you, so that's amazing.
Yeah.
Okay, so you're going to talk to us about something called Apache Hudi. Basically, something what you titled transactional data lakes using Apache Hudi. Before we get into the transactional data lakes, tell us what is Apache Hudi? HUDI.
Yeah, good question. And it's a tough one because yeah, you hear so many terms to describe what Apache Hudi is. And there is no one term that can really cover it all. But let me take a stab at it. So it's more than a table format.
Okay.
So if I would have to call it a generic name, I would call it a transactional data lake framework, if you will. But
Okay.
what does that mean, right? It's still very generic. But basically, it adds on top of your data lake some typical features that you typically have in a database or a data warehouse.
Okay.
Things like an index, things like transactions, things like record level updates, deletes, concurrency control, that sort of thing. Now, you might ask me why does that even matter, right,
Yeah.
on the data lake? And the thing is, well, we're using data lakes more and more often. I mean, they're getting ever more important. Why is that? Well, in the past, we used to put all the data in a database, and that was great because we knew how to use it. But with exploding data volumes nowadays, real-time streaming use cases and whatnot, and we collect a lot more data than ever before. Data warehouses and databases are getting expensive to scale.
Indeed.
Not only expensive, but also limiting us to what we can do with our data. So if we want to run machine learning or aggregate data across different sources and get some aggregate, deep insights out of that with analytics or machine learning or anything, we kind of need to move towards a data lake and put all
Right.
our data in there. Now, where do transactions come in? Well, if we want to do this at scale in production, companies kind of want to know, that their data
Yeah.
is the right data on there, that the quality is right, that if we're streaming data, that we're not missing anything, that we're not doing partial updates, things like that. So we need to
Yep.
ensure that our data is consistent. And that's where Hudi comes in. So Hudi offers these, database features on top of our data lake to make sure that
Right.
if
But
we want to stream into our data lake, yeah, go ahead, Darko. You want to say
so
something?
I'm just trying to wrap my head around this. So we're using data lakes because it's just cheaper to store data in data lakes, right? If we would just dump stuff in a database, it would be very expensive, right? That's correct.
Yeah,
Right. And we need some sort of a transactional thing feature on top of a data lake so we can do stuff with that data. I got my caffeine. Thank you. Thank you, babe. So the reason we want to do it is because we want to potentially delete records, update records in a data lake. I'm from Europe. GDPR is a thing. If you dump stuff in a data lake, you want to be able to delete some things when you are requested to, right? Is that the reason we would need something like that?
exactly, and other things too. But maybe a question for you or for the audience: how do you now delete? If you have to delete for GDPR, like you said, a particular record on your data lake, on S3, let's
Mm-hmm.
say, how do you do that? How do you go about it? And what's so hard about it?
Yep.
Why that is so hard is because of some of the specific, characteristics of data lake. Typically, your objects on the data lake are immutable. So if you want to change something, you have to download it, find the record
Yep.
you want to change, and then upload it again. Now, if you start doing that at scale, and if you need to find one record in your exabytes of data, perhaps, then you might be busy for a while. So that's tough. And there are other things too that Hudi manages for you. And I suggest we go to the console in a bit. I'll share my screen a bit, but basically, one other important thing with Hudi is file size management. So I don't know if anyone in the audience has streaming data ingestion into their data lake today and have some issues with that. Because if you stream data into a data lake, that's super fast. But what you typically end up with is lots of small files because you put the data in there as it arrives, and you want it in there as soon as possible. But then if you start querying it, you see a performance hit. Your read performance will be very bad, very slow, because read and query engines don't like small files. And that's also something that Hudi manages for you at the same time of ingestion, getting proper size files. But I'll just, I suggest I share my screen, and because
you share your screen. Yeah, you share your
can
screen.
be a, sorry, let me select the right one.
So after you share your screen, I would love to hear what exactly is Apache Hudi, right? In this sense, so maybe I can repeat it in my head again. Apache Hudi is an open source tool. Is it open source tool? Yes.
Yeah, it's absolutely open source.
That enables transactional features on top of a data lake. That means you can use your CRUDs or your SQLs. I'm not sure what exactly, but you can use some transaction elements on top of your data that you can do something like query, delete, whatever, right? And we have my friend back. We're going to transition back to Danny. Shana, just do it. Share your screen.
Show us what you got.
I'm gonna bump up your screen. Wow.
Yeah,
I'm gonna bump up your screen to the screen, and if you can, please
I'll zoom
a lot.
Yeah, that's maybe is that too much? But yeah, to clarify that point, Darko, so a good image is this one, and I'll zoom in. On the Hudi website itself, and we'll share that also. It's just like you can stream from any kind of data source into Hudi, but Hudi really, is a layer on top of your data lake. So you can choose to store your data in S3, in HDFS, or any other cloud storage. And then, you have a Hudi table on top that manages these transactions for you, these updates to your data on this storage. And then you can read with different engines. It's fully open source, so, they're open to many query engines as much as possible. So you can use Athena, we'll see that in a bit, Presto, Hive, Spark, and so on. So that is just to put a picture on where Hudi sits in this whole complicated thing.
Yeah, excellent. Okay, wow, that's okay, cool. So then show us. So you're gonna be doing this on top of S3, right?
Yeah, I'm going to just show you what that looks like and what Hudi actually does in practice, because it's going to be way easier to get rather than me rambling on about this topic. So just to show you, I created a bucket for this demo, and I have nothing more in it than a schema file that we'll go into later, but we don't need it. We don't have data yet. We don't have a Hudi table yet, so we're going to create that. And for that, let me zoom in as well. I'm using a Jupyter notebook on EMR just to start, creating a Hudi table on S3 and ingest data into it. So I ran this. I set up our Spark application quickly before the joining you guys here, because it would take a little while. But basically, we're going to name our Hudi table like Hudi trips table. I'm going to mock up some trips data, put it in there in a Hudi table to show you what that table would look like. But yeah, nothing to worry about here. So what I'm going to do first is generate some random data, really simple data. I'm going to kick this off right now. So I'm going to generate like 20,000 trip records, if you will, that just have a trip ID, like you can see here, a route, the destination, and the timestamp. So really simple table, but this gives us 20,000 records to work with and to ingest into a Hudi table. So writing to a Hudi table from Spark here in this case, it's nothing more than, we can write our data frame in the Apache Hudi format. We provide some options like our table name, like I showed you, and basically what write operations we want to do. So now we're going to insert the initial set of data to that location that I showed you. So let's just kick that off. Might take a little while.
So when you say you write data, so is this data? So are you writing this data to an S3 bucket right now?
Correct. So
yeah,
I'm writing this data to an S3 bucket in the Hudi format, and I'll show you that in a moment. And then at the same time, I'm also syncing that with our glue catalog, and I'll also show you this. So basically now it's done, our Spark job is done. So it inserted the data, at the same time it created the table because it didn't exist yet.
Yep.
If we now go to our bucket, we see here my trips table as a folder.
Nice.
So this is my Hudi data. What we see here is we have two Parquet files, basically containing our data, because Hudi stores its data in Parquet files. I use a very simple scenario.
Nice and compact and performant. We love Parquet.
Yeah, it's great for analytics, right? So for read performance, so that's great. So that's what we see here. And then what Hudi adds on top of that to do its thing of, giving you transactions, of allowing you to roll back to a certain state in the past, or, doing time travel or anything, it keeps a timeline. And this timeline is basically just metadata about what happened to your Hudi table and the data underneath. At what time? So every time
do you get
write
who
something,
modified it? Do you get who wrote it? How much insight do you get from all of those changes that are tracked with Hudi?
So right here, so these are not readable formats for us. What we can do is we can go into Hudi. Also offers a Hudi CLI. Then you can connect just basically to any path and can see a lot more details.
Nice.
Now you can't see who wrote what. That's a good one though. But you can see at what time, how many records were updated, how many files were modified or touched, things like that. So you can get a lot more detail, but this basically shows you like what Hudi does on top of your data, because it's just Parquet files, but it adds some like timeline to it so that you can at any point go back in time.
And is this data immutable? Is this like do we see all of the changes like a GitHub repository, like a Git repository, or do we lose all the changes? Can we track the history of a change?
Absolutely, absolutely. And you can even tell Hudi, and I'll show you that in a bit as well, like show me what my Hudi table looked like 3 hours ago or 5 commits ago. So you can do that too. So if
total time travel, like you said, that's really neat.
I love that.
Yeah, so you can roll back if someone made an error and ingested the wrong data, you can just roll that back, which is really nice to get on top of a data lake.
Okay, Shana, just to ask you here, like this sounds very amazing to me. Like, and when in my head, like, oh, it's a database, right? But why is this different than a database? In my head, it's a lot more data. And when we're saying a lot more data, what size of data are we talking when we're dealing with a data lake that has Hudi on top?
You can basically use that for any size. So there is no size requirements, and Hudi is just a layer on top. You're writing to it. In our case now, we're writing to it with Spark on an EMR cluster. And if we read through Athena, for example, those are the services that really define our limits. So for example, if we have a really small EMR cluster, writing petabytes of data, it might not be performing great. But S3 can handle it. The underlying services that we use, those limits are the ones that we need to take into account. But of course, those are much higher with the data lake on S3 than with a database, also much less expensive.
Okay, and like, would you use this thing for like data streaming? That is also key thing. We talked about a lot about data streaming here, and we can see potentially like people throwing streaming data into an S3 bucket. How fast can Hudi take that streaming data and do something with it?
Yeah, so Hudi is actually pretty amazing at streaming data ingestion, and you bring me to the next part, but let me just jump right there. So Hudi has two table types, and one is really great for streaming data ingestion. And the table type is called merge on read. So we could choose to use a different table type. And what that does, let me just run that as well. What that does is it's not going to store all our data in Parquet files. Well, at first it is. If you insert new records, it will go into Parquet files, columnar files. But any update that you make to that data will be stored in row-based log files. And that is much faster to write to. So then you can just stream, in real time into your data lake, and you're not limited by the speed of, having to write Parquet files or update Parquet files. You're just ingesting rows, which is typically much faster. So,
Right.
Yeah, go ahead. Was there a question?
No, one of the things that we've got today from the audience here is that there's a significant interest in services that have a lot of integrations, right? And when we look at a Hudi database here and a Apache Hudi on top of it, what services, what tools, what frameworks, what open source tools can be used to actually consume this data or interact with data through a Hudi database?
So there are many. I won't be able to list them all, but you can use, so for ingestion, you could use Spark Streaming, you could use Hudi's Delta Streamer, which is a tool that they create, or an open source tool that they create to stream into your Hudi tables. You can use Flink. You can read with Presto, with Hive, with Trino. Spark. So in AWS, you can use Glue, EMR, Athena. You can even query it with Redshift Spectrum as well, which is great, for the whole lakehouse thing. On top of
lots of options.
Lots of options here. Okay, please continue with your demos. Sorry for breaking it.
No worries. I do have to jump now a little bit more to the top, just to show you what will happen, but that's okay. So I created now a different table type, but I need to actually go and modify a record so that you can actually see what the difference is. So what I'm going to do is just select one record of my table, trip number 1000, so that I can modify that one. Now I hope everything's still working. So I'm going to select this trip with destination Seattle, and I'm going to change that destination to Boston. So I'm going to just, modify the data frame and then push that to my Hudi table. So, we'll see trip change to Boston. So if I now observe this with an observed operation, just, to that table I created, we'll run this. This is the initial table that I created that only uses Parquet files, which is called copy on write. Because copies your Parquet files every time it has to update something. And I'm going to also push that record to the second table that I created, which is great for streaming, the merge on read. So I'm going to push that same update to my second table, and I'll let this run while showing you what happened. So initial table, what you'll see is I had two Parquet files before that were created at 41. And now I have another one created at 49 that was basically created because I pushed an update. What you'll see is that the prefix of this file is the same as this one, meaning it's a new version of this file. And because Hudi gives these versions, you can perfectly roll back in time and go back like, oh no, I made a mistake, or we need to show an auditor what our table looked like 5 days ago. Then these versions will help you do that. But what you'll see is that
really, I was just going to say, I think it sounds like a really great option for time series types of use cases, and could see it fitting really well into that. Would you say that's the case?
Yeah, absolutely. Because with a time series, so typically you're streaming and then into your data lake in real time and partitioning on days, and then in all the downstream applications or ETL that you have, you typically just want to process the last bits that changed in your Hudi table. And so Hudi allows you to easily extract that because it keeps track of, what was changed at what time, so that you don't have to reprocess all the previous days, for example, if you're dealing with time series.
Brilliant.
Brilliant. I love that. Now, when it comes to like, sorry, are you done with your demo?
No, can I show one more thing?
Please show
two
whatever
more
you
things.
We'll
want.
just keep asking questions.
We're just throwing stuff.
Okay.
But yeah, go for it.
So this was the
Sorry, we'll
first
be quiet,
table.
we promise.
So this is great. No worries. But I just don't want to confuse everyone. So this is great for, this table type is great for more like batch kind of loads, or when you upload like data every hour. And then you just typically, you create a new version of your Parquet files. But if we go to a different table, the merge on read one,
Cool.
what we see here is that we had 2 Parquet files created initially at 47, but then our update record got pushed to this log file, which is an Avro-based file. And you'll see that this is totally different and much faster to ingest streaming data.
Yeah.
How Hudi does this
Makes
is
sense.
to give you, good read performance. It compacts these two basically. At every now and then, it does that, at the time of writing, or you can do that separately. But you can merge. It merges the log files with the Parquet file, so that your query engines get the benefit of reading from large size Parquet files and don't have to read the log files anymore. But yeah, then you get great write performance, fast data ingestion with streaming, real-time use cases, and also really good read performance. I will show you that process if we have time left, I can show you that at the end.
Go for it. Now,
Okay, but
once you're setting it up, I just have a question here. If you're ingesting data into a data lake and you want to use Hudi on top of it, do you have to change your data ingestion methods and create this Hudi table, or is this completely independent from using Hudi? Like, do I have to ingest data through Hudi, or just dump stuff into a data lake and use Hudi on top of it?
So yeah, you typically write in Hudi format if you want to have Hudi. So then, if you already have like an existing data lake and that uses, for example, Parquet files, then you can simply bootstrap with Hudi. So tell Hudi like, there's my bunch of files that I want to be in Hudi format, and it will take care of it.
Good. Okay, please show us the rest of your demo.
Okay, let me zoom in.
Zoom in, please. Thank you.
Now let me just, so I just wanted to show you what then actually these Hudi tables look like. So I'm going to use the first one that I created. And what you'll see here is that, we have this data that I mocked up, the destination, route ID, and timestamp, but Hudi added some columns to it. And that is how basically the whole thing about Hudi, how it does its thing. So it keeps track of what keys you have, what partition they belong to, what file they are in, at what time you committed. And all this metadata really allows Hudi to basically easily find your keys. If you need to update a record, it has an index on this record key and it knows exactly what file to find this record in, rather than have to scan your entire, open all the files and scan through them to see which file might contain this key or not, and then update it or create a new file. So you'll see here that, these fields, right, this extensive zoom is not working so great, but you'll see here that basically it gives that commit time, a sequence number, a record key, which is my trip, the file, and then just our data. So it gives, that whole timeline to be able to roll back, but also then, record level metadata, so it can easily find your records that you want to either delete for GDPR, like say, I need to delete everything about person X,
of course,
and find it easily, or update.
And would it delete all of the things even in the time machine history? Would you be able to do that?
It is a tricky thing, and now we're going into deep stuff.
Getting in the weeds.
So it can, but with the multiple versions that Hudi keeps, like I showed you, the multiple file versions, if you just delete, a new version will be created that doesn't contain that record anymore that you deleted. So then I ask Athena to query that data set for me, and I won't see it anymore. But if I go and roll back to a previous time, then there it is again. So that is where, you need to do your file cleaning, which is also covered by Hudi, but you need to tell it like, I want to keep this many file versions or this many in my data lake. You need to, narrow that down if you don't want people to be able to roll back to and recover GDPR deleted data.
Okay, no, fair point, fair, and that's something you need to take care of, especially when it comes to huge data lakes and a lot of data.
Yeah.
Now, Shana, we're reaching closely to the end.
Yeah.
Did we miss something from your demo? Is there something more you want to point out, share,
Beguile us with.
beguile us with?
So I think I pretty much covered it all. I mean, I can go hours about Apache Hudi, but I would
We
just
love
say,
that about you.
Yes, thank you.
I would just say try it out for the audience, because it is hard concept to explain in 25 minutes, but it's not that hard to learn. And we do have here at AWS, we create great workshops, blog posts, everything about Hudi to show you how to get started, really simple, and roll up your sleeves and get hands-on with Hudi yourself on AWS. So I would recommend everyone, we'll share the link to a workshop that's great for getting started. Just try it out. Check our blog posts to do that. But yeah, there's a lot of documentation about it. We can talk about it for hours, but I would just say try it out. If you're doing data lakes at scale, go to Hudi.
Thank you, Shana. The links for the workshop is there on that side, so it's in the chat. You can check out the workshop and play around with yourself. Please make sure to give us feedback on Shana's session. You may get a credit code for AWS, so check that out. Before you leave, Shana, one last thing. If I ask this to everybody, if you have a button you can push that will add, remove, or change a feature to Apache Hudi, I guess because this is on EMR, maybe EMR, what would it be?
One might be to be able to ingest to multiple tables using Spark streaming more easily. And then another one, and one can only dream, right, is that it is a bit far-fetched, but that EMR would somehow auto-scale, not auto-scale, but auto-configure all its sizing, memory, and everything for Spark. If you're doing Hudi, like monitor your Hudi workloads ingestion, and then auto, adapt its Spark config, its EMR cluster size, all those kind of things. The tricky parts.
One can only dream.
One can only dream. It's true.
Don't we wish there was a thing that can automatically scale without us ever thinking? We used to dream about that. We have serverless stuff now.
Yes.
So, but yeah, heading in the right direction. Shana, once again, thank you so much for staying up late with us.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.